This lesson is going to be about solving exponential equations when our exponent has a variable in it. And with this process, we're always going to be using the log of base 10. So I'm not even going to put the 10 there, I'm just going to put the log. So to start off with, let's say for instance that I have 9 to the power of x equals 45. Okay, so I know that 9 to the first is 9, and I know that 9 squared is 81. But there is some type of number in there that I can find out when 9 to the power of that number equals 45 using logs. So I'm going to rewrite this. So I have the log 9 to the power of x equals the log of 45. Okay, so we know that with this 9, when it's to the power, I can put that x on the outside. And this is all based on the properties of our logarithms that we should know and have done before. So now I've got the x on the outside. So looking at this, if this were, any type of other algebra problem, what would I do to get x by itself? I would divide by log 9. So x then is the approximation of log 45 over the log of 9. So I'm just going to plug that into my calculator, and I see that x is approximately 1.732. Okay, do you see how everything is a manipulation of our logs and using those properties? So another thing, let's get a little bit trickier. I'm going to get a little bit trickier and then give you a question on it, okay? So let's say though that exponent is actually an equation or an expression. So let's say for instance I have 6 to the power of x plus 2 equals 17.2. Okay, the process we start off is the same. I'm going to have the log of 6 to the power of x plus 2 equals the log of 17.2. Because that 6 is to the power, we're going to split that on the outside. So I have x plus 2 log 6 equals log 17.2. Okay, a lot of people will think, okay, I can just divide by log 2 and then minus 2. Or divide by log 6 and then minus 2. That's not the case. This x plus 2 is together. So hence the parentheses. We actually are going to split this. So what do I mean by splitting? What I mean by splitting is I'm going to have x log 6 plus 2 log 6 equals the log of 17.2. Now that that x plus 2 is split, I can go ahead and solve it algebraically. So I know that x log 6 has to equal the log of 17.2 minus 2 log 6. Okay, so to get x by itself, now I'm going to take all of that top part and divide it by log 6. When I plug this into my calculator, you want to put all of this top part in parentheses, otherwise it's going to do the division first and then take that and subtract it. So you need to make sure that you're letting your calculator do the order of operations as you see it versus what it thinks. So when I plug that in with my parentheses on the outside, x is approximately negative 0.412. Okay, so you guys are going to have a problem that's similar to this one, and you're going to give me what the x is approximated. So for you guys, are going to have 2.1 to the power of x minus 5 equals 9.32. Good luck. First thing I'm going to do is I'm going to write this in my log form. If you would like to skip this step and just jump to the splitting, that's perfectly fine. I understand it. So I'm going to put my power on the outside. So I have x minus 5 log 2.1 equals log 9.32. I'm going to split this x minus 5. So I have x log 2.1 minus 5 log 2.1 equals log 9.32. Okay, so in order to get x log 2.1 by itself, I'm going to add that 5 log 2.1. It's a lot of writing, I know. So then from here, I'm going to go ahead and divide that out. And once I plug that into my calculator, I will see that it equals approximately 8.009. The last thing we need to cover is the change of base. So everything that we have done, or anything that we have entered into our calculator, it's always been the log, technically base 10 of some number, and when it equals whatever. Well, what happens if I have log 8 of 2? What does that equal? We know that we can plug this one into our calculator. Well, if my log is a base 8, there is a special way that you can figure this out. In order to look at this, say this equals x. X really equals the log of the big number over the log 8. Notice that the bases here are the same. The bases are both 10. So with this being said, I can now plug this into my calculator and actually divide it. So the log of 2 divided by the log of 8 is 0.3 repeated, aka 1/3. So what that means, the log of a to the n equals the log, we'll always just use 10, so in the book it has a b there, but we'll just use 10 because we know that's what our calculator will use, is the log of 10 to the n over log 10 to the a. Some conditions here. A cannot equal 1. And I'm only saying that because that's what we have for sure. When you plug in log of 10 of 1, that equals 0. And we know that we can't divide by a 0, hence why a cannot equal 1. Okay, so I've shown you an example of this. Here's your question. X equals the log of 5, base 5, of 23. So go ahead and calculate your x. Looking at this, I know x has to equal the log of the big number, the 23, over the log of 5, And I just plug that right into my calculator. And I see that x equals 1.948.